Okay, I think we're going to get started then. There we go. Hi everyone. Welcome back, my good old chemistry kings and queens. My name is Nketia, and we're back with our fifth. That's right, our fifth chemistry squad. I hope you're all really excited. I know I am. Today we're going to be going over rates of reaction. Definitely one of my favourite topics in GCSE chemistry to cover. And I'm really excited to go over some of the fundamentals in preparation for any mocks that you might have coming up. Um, I can see a few people are sort of rolling in, so great to see you. Don't be afraid to say hello, just sort of pop a hi in the chat or a smiley face or waving emoji, whatever you fancy, as long as it's PG. So by all means, do say hello. Just as I always say, do make sure to check out the other squads that happen in the week. I do believe that there is one on a Monday that happens. I think Sarah does that as well, and that's all about maths. So do make sure to check out that squad as well. Hello, Inga. Good to see you again. I hope you're well. Great to have you back moderating our chat. Good to see you again this evening. Hope you've had a good day. See a few more people rolling in, so don't be afraid to say hello. We're gonna get things kicked off in the next 3 minutes or so. Um, so, you know, just get comfortable, get a cup of tea. Not coffee though, because it's 5 o'clock. It's much too late for coffee, in my opinion. Hello, Charlie. Good to see you this evening. Hope you're well. Hope schools have been good also. Hope you've been smashing chemistry. I'm sure you have. Great to see all of you again for another exciting chemistry squad where we're going to be going over rates of reaction. It's great. The weather's actually been a lot nicer. I'm just making small talk before we get started. The weather's been a lot nicer. I think when I drove into work today, it was actually decently warm. So hopefully the weather's good where you all are as well. Me, Sam, hello. Good to see you. Hope you're well. Hope you've had a good day so far. Hope you've been smashing chemistry. I'm sure you have. So great to see you. Thank you, Inga, for putting that link in the chat. Guys, do make sure to click on that link if you do have any friends or not work colleagues, school colleagues that might find these squads helpful. Do make sure to check out the link with them. And they are also good reminders for you all, so you never forget to tune in at 5 o'clock on a Wednesday to join the best chemistry squad that is out there at the moment. How am I? I'm good, thank you, me, Sam. I'm good. Today has been a very busy day. I don't know whether I'm sure I've mentioned it before. At the moment, I'm a hematology and oncology pharmacist, and today's a very busy clinic day in terms of oncology. So it's always a bit of a busy one, but it's been good. It's been productive. I've been staying positive, so it's been a great day, and I've got a brilliant team. So I couldn't really ask for much more, to be honest. It's been fantastic. Hope you've been well also. Most importantly, I'm super excited to go over some chemistry with all of you this evening. Hope all of you have loads of questions, and I hope all of you are raring to go and get engaged as much as possible and answer loads and loads of questions that I'm going to put in the chat. We're going to give it one more minute, and at 5:05, we're just going to hit the ground running, and we're going to kick start off with rate of reaction. It's going to be really exciting. Before we get started, I think it would be great if all of you just put some words in the live chat that you would relate to rates of reaction. So that's my first question for this evening. What words come to mind when we think of rates of reaction? So what comes to mind? What do we all think? Let's see some engagement in the chat, guys. The more engagement, the more likely I am to put on my little gold trophy that I always do every week. So, again, just once again, everyone, prove to me that you are the absolute best chemistry squad that's out there at the moment, or just out there, period. What words come to mind when we think of the phrase rates of reaction? What do you guys think of? What are some buzzwords that come to mind? Be great to see lots and lots of engagement from all of you. What do we all think? I'm going to kick the ball off. I'll get the ball rolling. I'll use the word catalyst. I think catalyst is definitely one. Me, Sam, thank you for getting the ball rolling. Energy, great. That's definitely a word that I think is relevant to rates of reaction. I think that's good. That's a great answer. Well done. What else comes to mind, people? So me, Sam's given us energy. Let's keep the ball rolling. So what else can we think of? Right, so I've said catalyst, me, Sam said energy, something else. What other words come to mind when we think of rates of reaction? I give it 2 more minutes to see what all of you come up with. So what other words come to mind when we think of rates of reaction? Okay, I'll tell you what, we'll keep the ball rolling. And if anyone else has any other suggestions, then by all means, just pop them in the chat and I will come back to them. But I suppose rates of reaction, this topic, which I suppose some people sort of refer to quite nicely as kinetics, this really looks at how quickly reactions happen. Okay, so how quickly reactions occur. Now I'm going to use an example, okay? Let's say, for instance, you have a reaction in which A plus B goes on to form AB. Okay, as I say, it's just a combination or something to that effect. Okay. Oh, actually, I realised you can't actually see all of the screen. Let me move this a little bit. There we go. That's a bit better. So, when we think of rates of reaction, we're thinking about how quickly reactions occur. So I have this standard equation, which I suppose you could put any chemicals into. A plus B gives you AB. And so what we can think of when it comes to rates of reaction is we can think of how quickly AB is formed, or we can think of how quickly either reactant A or reactant B are lost or transformed to form AB. Okay, and that's really what kinetics looks at. Whenever we think about kinetics, the other thing to keep in mind is that we can also consider ways in which we can measure the rate of reaction. Now, I know a few more of you have joined. Great to see you. Hello. I was just asking what are some of the other ways in which we can measure the rate of reaction generally. So one example that I am going to offer is I'm going to say we could measure a change in mass over time. Okay, and I think this is a very classic one where you may get your reaction mixture on a balance, on a scale of some sort, and you may then measure the difference in mass from the beginning of the reaction to the end of the reaction over a specific period of time. Okay, and generally the idea behind that is that if you were to have a reaction which produces a gas, when the gas leaves your reaction mixture, that gas still has a mass. And so if it's no longer in the conical flask or the reaction container, then the consequence of that is that the balance, the reading on the balance will decrease. Okay. Now, that being said, the other thing to consider is that there are other ways in which you could measure the rate of reaction. The other thing as well that you could do is you could measure a color change. Okay, so how long does it take for a color change to occur? This is another thing that you could sort of ask yourself when it comes to measuring the rate of a reaction. Okay, you could also look at other ways to measure the rate of reaction. Another way could involve maybe a change in conductivity. I butchered that spelling. Conductivity, or even a change in pH over time. Okay, so these are not an extensive list of ways in which you can measure the rate of reaction, but there are certainly 3 or so that immediately come to mind. Evangeline, hi, good to see you this evening. Hope you're well. Hope you're excited for another chemistry squad. But we're going over rates of reaction. You've not missed too much so far. Now, I think the thing to think about here with regards to rate of reaction is that this all relates to time. And this is really important, and it's a really important concept I want all of you to remember. The idea of rate when it comes to kinetics and chemistry is always related to time. It is thinking about how quickly a change occurs. And by me using the word quickly, that denotes that time is a factor. And I'm going to give you 2 examples. If you have a car that is covering a very large distance over a short period of time, it's going at a fast speed, isn't it? Okay. The converse to that would be if it's covering the same distance but over a longer period of time, and therefore we'd consider that it's going slower. So in the same way that we think about speed with cars, when we think about rates of reaction, we also have to sort of consider the element of time, because that is also important. Now, one thing I'm going to do is I'm going to draw a graph to sort of exemplify my point a little bit. So if I draw a graph, or attempt to draw a graph, like so, we could have time on my x-axis, and we could have the concentration, let's say the concentration of AB, for instance, on my y-axis. And you'd expect it to look like that. And the reason we'd expect the graph to look like that is because at time 0, we don't have any of my product. But then initially the rate of reaction is going to be very, very fast, okay? Because I have the maximum amount of AB as possible at the very beginning of the reaction. But as time goes on, my concentration of A and B is decreasing because it's being used up to form AB. So then the graph then starts to curve until it reaches an endpoint almost. Now what we need to remember is that any graph that plots concentration against time, the gradient will be the rate of reaction. Now, does that make sense for everyone so far? Hopefully it does. Give me a quick thumbs up or a smiley face in the live chat if it does make sense. If it doesn't make sense, then please do shout and I will happily go over it again. Okay, super, super important that you guys understand this, because these graph questions come up in exams quite often. You may be asked to draw a graph or sketch it. You may be asked to interpret the graph in terms of the rate of a reaction. And so it's really important to remember. So Misam, you've asked what the gradient is. Good question. The gradient is the rate of the reaction. Okay, so I'm going to type that out for you. Now, if your question was more, well, what is the gradient? Well, the gradient can be calculated by doing what is called rise over run, although you may know that in maths as delta y over delta x. Okay, so we'll put change in y over change in x. Now, this works when you have a complete straight line. When you have a curve like this, on the other hand, what you would do is you would draw what is called a tangent. And a tangent is where you would draw a straight line that just intersects at the point of the graph you're interested in, and then you would take the gradient of that line. Does that make sense? I hope that's answered your question. And I hope it's answered anyone else who may have had the same question. Okay, because that's a very good question, B. Sam. Thank you for asking that. Because I think gradients is definitely an area that can catch a lot of people out. I know it caught me out at GCSE a couple of times when I was revising. And even still caught me out at university when I had to do graphs, but not for rates of, well, sometimes for rates of reaction. Yes, could you do a tangent on the graph? I certainly can. So what we would do is we would draw a line. Here we go. And so let's say I wanted to get the let's say the gradient at this point here, I would do something like that. And then what I would do is I would then calculate the gradient of this line, like so. Okay. Lovely. Does that clarify things a bit? Hopefully that makes a bit more sense. Okay, that's what your tangent would look like. Perfect. I'm glad that's made sense. Fantastic. So that is what your gradient would look like. Now, the second thing, or the second part of this squad I really want to focus on are the different factors that affect the rate of reaction. Now, I can see quite a few viewers in the room this evening, so I want to see loads and loads of answers, guys. I want you all to tell me what factors affect the rate of reaction. Oh, sorry, before we go on, Evangeline, you said no. Evangeline, is that no in respect to you didn't get what I was talking about? If so, do you want me to go over it again? Happy to go over it again if needs be. But we've got temperature from Charlie. Fantastic. So temperature is definitely a factor that affects the rate of reaction. So I'm going to scroll. Let me see. Let's see. So we'll say factors that affect the rate of reaction. And we've said temperature. Great. So we're going to put temperature there. I know it looks super messy. I'm just going to move the text. Fantastic. Cool. Oh, so Evangeline, you're in year 7. Okay, so it may very well be that you go over this content a bit later on, maybe year 8, year 9. So if it doesn't make sense right now, that's okay. Don't worry, okay? But it might mean that when you go over this later on, it feels like a bit of a recap to you. So don't worry if it doesn't make that much sense. Most of this it's tailored to GCSE. Misam, you've said amount of CO2. So I would agree with that. What I'd probably say is I would rephrase that to concentration. Okay, so concentration definitely affects the rate of reaction. Very good. And Lara, hi, thanks for joining this evening. I can see that you've said pressure. Fantastic. I'm going to add that one in there as well. So we've got 3. Now there are 2 more things I think affect the rate of reaction. I'm sure we can definitely remember them, guys. There are 2 more things that affect the rate of reaction that I can think of anyway. So Misam, you've said time. Well, time, I wouldn't quite say that time affects the rate of reaction. I think time is relevant to the rate of reaction, but I wouldn't quite say it affects it. Yes, it's true that if time goes on, the rate of reaction decreases, but that tends to be because of other factors, not because of time itself, if that clarifies things a bit. But good answer all the same, just not quite in line with that of temperature, concentration, and pressure. I'm going to add one to the mix. I'm going to add catalysts. So catalysts definitely affect the rate of reaction. Catalysts. And then let's think of one more. Can we think of one more, guys? One more factor that affects the rate of reaction. What are we thinking about? I'll give you all a clue. It consists of 2 words. Yes, Misan, well done. Smashed it, mate. Surface area. Okay, so great. Surface area is the other thing that affects the rate of reaction. Okay, now let's have a think about all of these different factors then. At GCSE, what's super important isn't just that you know that these factors affect the rate of reaction. It's also that you're able to explain why they affect the rate of reaction. So let's start off with temperature. Does anyone want to have a go at explaining why temperature affects the rate of reaction? And interestingly enough, there are 2 reasons why temperature affects the rate of reaction. And this is actually quite interesting because when I was at GCSE, I only sort of remembered the one. But there are 2 sorts of arguments as to why temperature affects the rate of reaction. So what do we think, guys? Who is going to be super brave and answer that question in the chat? Who's going to give us an explanation? Hopefully all of you, because you guys are absolute chemistry geniuses. Ardil, hey, good to see you, mate. When temperature increases, the reaction gets faster. So that's good. I'd agree with that. My question is, we're gonna try and drill down that answer. We need to try and drill down that explanation. Okay, why is that? Okay, so again, similar to me, Sam, why is that? Okay, so why is it that if we increase the temperature, the rate of reaction increases? What's the underlying science? And I think this is one thing that as a tutor, I always try and get my students to do. Okay, pretend that the examiner knows nothing about chemistry whatsoever. Okay, and so you're almost explaining it step by step. Okay, so let's think about this. So Misam, you've said that particles collide more. Okay, so now we're getting somewhere. Now we're drilling down to the actual the nitty gritty of it. Okay, so let's talk a little bit about this then. Anytime I answer these questions in an exam, I always do it step by step. So the first thing that I would say is temperature increases the rate of reaction. Oh, hang on, I think we've got an answer. So Lara, you've given us a slightly more detailed answer. Let's see what you've said. When temperature increases, the atoms get more energy, they'll move faster, and therefore they're more likely to collide. Okay, that's a really good answer. Well done, Lara. So when temperature increases, your atoms will vibrate more. Okay, you've now supplied your atoms with more energy. Therefore, they move around faster. That's your first point. Therefore, they collide more often. So I think the classic line is that there's an increase in the frequency of collisions, successful collisions, I might add. That's your second point. And therefore, the rate of reaction increases. So 3 points there. So the first is that temperature increases, and therefore the molecules have more energy and therefore move around more. The second point is therefore, because they move around more, they then collide with each other more frequently. So there's an increase in the frequency of successful collisions. And the third point is that therefore the rate of reaction increases. Well done, guys. You smashed that. The other thing as well to remember, and who was it that said this? Ardell, you pointed this out, that temperature needs to be at an optimum. So it's true that you need to achieve the activation energy. If you increase the temperature, you could make the argument that more molecules have energy greater than the required activation energy. And as a consequence, that then means that your rate of reaction increases. Well done, guys. Oh, Lyrics, hey, good to see you. Hope you're well. Hope you're doing well, buddy. Great to see you again this evening. So we're going to put a nice green tick next to temperature. Does anyone have any questions at all about how temperature affects the rate of reaction, or are we all on the same page? Are we all happy with that? Give me a quick thumbs up in the chat if we're all happy with that. I'm going to put a nice green tick next to it, but just want to double check. Don't want to move on until we're all on the same page. I want to see loads and loads of ticks, loads and loads of thumbs ups, or smiley faces. Anything positive that would suggest that you've understood what we've talked about. Hopefully that's made sense to everyone. See a thumbs up from Lara. Fantastic. Great. Any more thumbs ups? Or smiley faces? Or anything to suggest that you've understood it? Because again, I'm always more than happy to go over it again if it's not made sense. Misam, yes, well done. Fantastic. Great to see a smiley face from you there. Okay, we'll get one more smiley face with thumbs up and then we'll move on to concentration. I'm wary of time as well, so I think I might, no pun intended, speed through the rest of the factors. Okay, so let's think about concentration. Concentration affects the rate of reaction, again, for a similar reason that is related to temperature. Again, it's all to do with an increase in the frequency of successful collisions. If I increase the concentration of my particles, then my particles are going to be more likely to collide with each other. This then increases the frequency of successful collisions, and this therefore increases the rate of reaction. Okay, fantastic. We can also apply the same thing to pressure. Okay, so pressure Oh, so Misam has asked, is it possible if I can continue till 6? So unfortunately not. The study squads are actually only commissioned until 5:30. So unfortunately I've only got half an hour, which, obviously makes it a little shorter. I know last time they were a whole hour. So if that's a bit of feedback that you want to give, then definitely, I know Inga will put a link in the live chat towards the end. Do put that feedback in because that does help us. If we're more likely to for you guys to enjoy the 1 hour slots rather than the half an hour slots, then we'll go back to the hour slot. But for the time being, yeah, they're only half an hour, which is a shame because I do enjoy these, and if you guys enjoy them, then then we should definitely try and give an hour if we can. But pressure is really similar in the sense that if you increase the pressure, you've got more particles in the same space. More particles, therefore, means that you get more collisions. The frequency of collisions increases, and therefore the frequency of successful collisions increases, and therefore that increases your rate of reaction. Surface area. Now, surface area is a really, really interesting one, and I always like to sort of compare it to sugar. If you have a cup of tea and you have a sugar cube and you have granulated sugar, if I put both in the tea, assuming that both cups of tea are the same temperature, what will dissolve first? We know that it's going to be the granulated tea. The granulated tea is going to dissolve first because it's got a greater surface area. If the surface area is greater, that means that there are more surfaces of the reactant that can collide with each other correctly. This then increases the rate of reaction because it increases the rate of successful collisions. Okay? And finally, let's look at catalysts. Catalysts increase the rate of reaction because what they do is they offer an alternative reaction pathway. That's right, they offer another way of reacting that generally has a low activation energy. The way that I like to sort of think about it is if you imagine you were doing the high jump at school, only X number of students can make the high jump. But if you put a springboard in front of the high jump, then a greater proportion of students can make the jump. So I've not changed where the bar is, but I've made it easier for more students to get over the bar. Same thing with catalysts. Catalysts offer a different reaction pathway that has a low activation energy, which then means that a greater proportion of molecules with a certain amount of energy can react. Okay, they can get involved in the reaction, and this also increases the rate of reaction. I need to stress that at GCSE, you do not need to know the details of every single catalyst under the sun. You will need to know a couple of catalysts in particular, but you do not need to necessarily know how they work in great detail. Okay, if in doubt, do refer to your specification, whether that's Edexcel, CIE, AQA, or Educas. So one of the four. Okay, or OCR. I must forgot about OCR there. Do refer to your specification. And with that, I would say that nicely sums up everything that there is to know on rates of reaction. Yes, it was a bit of a crash course. Again, no pun intended. But hopefully that made sense to all of you. Okay. I will hang around for maybe 5 minutes or so. So if anyone does have any questions, I'm more than happy to stick around and answer them. But thank you, Inga, for putting that link in the chat. We do hope that you enjoyed the session today. And please leave your feedback. It is super, super important because it means that I know where to improve if there's something that I do that you guys don't like. And it also means that my tutor knows what it is that you guys want from these squads. We're really, really keen to keep these going. And there is no squad without you guys. And we really want to know what exactly you want to learn. We want to know what topics you guys want to learn. We want to know how long you want the squads to run for. We want to know how often you want the squads to run for. Every single thing that we could know, any bit of feedback you could give us, please give us, because it helps us create a better experience for all of you. Yes, Misam, I can explain catalysts again. So catalysts, the way they work is they offer an alternative reaction pathway. So what they do is they almost offer a different path which has a lower activation energy. So if you imagine, here's a different example. Let's say you had to drive from A to B and it was a really long distance. But then someone said, well, I know a shortcut. Well, a catalyst is like a shortcut. Okay, it's a different way of a reaction, and that way has a lower activation energy. And because it has a lower activation energy, this means that a greater proportion of molecules have sufficient energy that's greater than or at least equal to the required activation energy. Does that make a bit more sense? Hopefully that explanation clarified things a bit more. Give me a quick thumbs up if it did. Because if not, again, always happy to re-explain if needs be. But yes, that is how catalysts work. Does anyone else have any other questions at all? Oh, Evangeline, see you. Thank you for joining this evening. Again, make sure to give as much feedback as possible before you leave this evening. But yes, I will hang around for another 2-3 minutes. So yes, it does. So lower activation energy is. So I wouldn't say a lower activation energy is bad at all. We don't necessarily want a lower activate. No, we don't necessarily want a higher activation energy because higher activation energies are associated with slower rates of reaction because statistically you'll have fewer particles that have that amount of energy. So if anything, having a lower activation energy is better because it means that you get a faster rate of reaction. Okay, so a lower activation energy results in a faster rate of reaction. Okay, so I wouldn't quite say it's to do with it being bad or, well, it's not bad at all. If anything, it's a good thing. Okay, fantastic. I'm glad that makes sense. Smashed it. Not a problem, me, Sam. I'm glad that made sense. Okay, I think we're going to give it 2-3 more minutes or so, and then afterwards we are going to say goodbye for this week. This is actually our 5th chemistry squad, which means we have 5 more to go, and then that's it for this round of chemistry squads, actually, which is always a bit of a shame because, again, it's always fun doing these. I am going to see what we've got going on next week. I have a feeling it's reversible reactions. I think that's what I had scheduled for next week. I'm going to be really cheeky and just have a quick look. That's right. Reversible reactions is what I've got scheduled for next week. Feat Le Chatelier, or featuring Le Chatelier. Another chemistry fun. Ardil, how's my day been? It's been good, thank you. It's been very good. It's been busy. I was just saying at the very beginning, at the moment I'm a hematology and oncology pharmacist. And Wednesdays are always quite busy because we have like really heavy clinic days. But no, I've got a brilliant team that I work with. Everyone's always super helpful, and it's really great to make a difference in the lives of patients, particularly in an area like cancer. So it's great. Yes, I'm a pharmacist. I guess I'm a relatively young pharmacist, but yes, I'm a pharmacist. Sam, what inspired me to go into? Well, strictly what inspired me to go into pharmacy rather than medicine. Um, so this isn't a Breaking Bad joke at all. I always found the way that medications worked interesting. I wanted to sort of learn why we supply certain people with certain medications. So what prescribing pathways result in certain outcomes. So how is it that we know that salbutamol works, for instance, for asthma? How do we know that carboplatin works for like cancer, for instance? So originally I actually applied to do pharmacology at Edinburgh. I then thought to myself whether I'd be able to get what my employment prospects would look like after a pharmacology degree. So then I actually went through adjustment. So I actually went to Durham University through adjustment on results day because I ended up scoring higher than I expected to at A level. And I ended up doing pharmacy, and here I am now. So that's kind of my route to pharmacy, as it were. Oh, you're looking to do something pharmacology based. That's cool. I would definitely recommend pharmacy. I know with the way the NHS looks, it doesn't necessarily look great, but there is a rewarding aspect to it. So, but that's my opinion anyway. I always encourage you to do your research, speak to people as much as you can to get your own opinion. What did I do at A level and what did I get? So for AS, I did bio, chem, physics, and French. I then dropped French at AS, and then did bio, chem, and physics. I got an A star in bio and chem, and I got an A in physics. So yeah, definitely higher than my predicted grades. I honestly think A level, I definitely studied like the hardest at A level. But yeah, that's what I did, and that's what I got. And it's funny because I look back on it, I think, oh, will I ever do that well academically again? Oh gosh, that was a fun time. Yeah, sometimes I miss A level. Sometimes I do miss A level. It was a good time. Okay, let's see. Okay, I think we'll give it 2 more minutes just in case there are any more questions. And then yeah, we'll jet off really soon. Hopefully, all of you have a lovely evening. Also, I know a lot of you have mocks coming up actually, like really soon. So I hope you're all revising, but I hope you're also taking breaks. It's really, really tempting to just work throughout, and it's just not feasible. You need to make sure you take breaks. You have to balance out revision and relaxation because by relaxing, you actually become more productive when it comes to revision. So it does feed back into the system, as it were. Okay, I think, unless there are any more questions, we are going to call it a day there. Once again, everyone, thanks for joining. Oh, you're trying to ask a question, but I'm not getting it. Oh, okay. Maybe it's because the question's too long. I think the chat might cut off after a certain number of characters. Yeah, I'll answer one more question before we head off, before we close for today. So yeah, so maybe try retyping your question. If not, don't worry. You can always pop it in the comments under the YouTube video itself, and I will, I'll reply there. So either or. Worst comes to worst, you could save it for next week, or just pop it in the comment section if it doesn't pull through. Sometimes the YouTube live chat's a bit funny. It's really unpredictable sometimes. It just does what it wants to do. Oh, perfect, Inga. Yeah, no, I'm in agreement. Yeah, pop it in the comments. Pop the question in the comments, and later on this evening, I will have a look and I will reply. Hopefully, hopefully you find the reply useful. But if not, we can get like a thread going or something. I'm sure that wouldn't be an issue. Okay, I think we're going to call it a day there, guys. Have a wonderful evening. Again, thanks so much for joining because there is no squad without you. And once again, all the interaction, all the positivity just goes to prove that you guys are the best chemistry squad out there. And I'm super, super proud to be leading the squad. I will see you all next Wednesday at the same time, 5 p.m. Don't be late. Make sure to be there. I will see you all next Wednesday. Take care until then, guys. Have a good evening. See you soon.